Hello, class. All right, so today we are going to continue on talking a little bit about factors, reviewing them, revising them. Then we'll get to talk about multiples. After we've figured out what that is in the lowest common multiple, we'll look at some questions and we'll talk about how to read and understand them. And then we will do some practice distinguishing highest common factor questions versus lowest common multiple. I do also have good news. I will be in Italy soon. I have a flight for this next week, so I'm not exactly sure when I will see you, if I'll be in class next week or not as of yet, but I will be there soon. So I'm very excited to meet all of you guys. Okay, so let's start with some revision. So I've got a statement here. It says Sophia is working out the highest common factor of 35 and 45. Without doing any calculations, decide how you know Sophia must be wrong. And Sophia has said, I've drawn a Venn diagram, and the highest common factor of 35 and 45 is 315. So you don't need to calculate it. Don't work it all out. You should be able to figure it out just by her statement. What did she say that was wrong? So take a moment, let's say a minute, talk to someone next to you, pause the video, and figure out what she said that was wrong. Okay, so last lesson we learned something that helps us here, and if we take a close look at these numbers, we can notice something. We have 35, 45, those are our base numbers, right? So we're looking for factors of these. And then Sophia is saying that the highest common factor is 315, which is bigger than these numbers. We learned last week that a factor of a number cannot be greater than the number itself. So 315 cannot be a factor of either of these numbers. It's bigger than them. And in this case, any number bigger than 35 would also not be the highest common factor, right? Because it can't be bigger than the number itself, right? So let's try another problem. This is a highest common factor problem. We have two groups. Group A has 30 students and Group B has 42. They need to get into the largest teams they can, but each group must have the same number in each team. Excuse me. So take a moment, take a minute, try and work this one out. How many students will there be from Group A and from Group B to make the largest teams possible? So pause the video, take 1 minute, try and work this out. Okay, so let's take a look at this. We can factor 30 and 42, right? So if we go through the factors, we have 1 and 30, 2 and 15, 3 and 10, 5 and 6 for 30, and for 42, 42's factors are 1 and 42, 2 and 21, 3 and 14, and 6 and 7, right? So 6 is the largest team that they can get into, right? Because this is the factor that they share. So 6 is your highest common factor that you're looking for here. Hopefully this makes sense. This is what we did last week. We'll do some more practice with this week. But now we're going to talk about multiples. And you probably know what a multiple is. Multiples are numbers obtained by multiplying a given number by an integer. So for example, multiples of 3 include 3, 6, 9, 12, etc. You can see here 3 times 2 gives you 6. That would make 6 a multiple of 3 and also a multiple of 2. Anytime you multiply something by an integer, you get a multiple of those two things, right? So 1 times 2 is 2. 2 is a multiple of 1 and 2, right? So I've got a question for you. How many multiples does 10 have? How many multiples does 10 have? Take maybe half a minute and think about this. Maybe write down your answer in your notebook and then we'll talk about it. So how many multiples does 10 have? 10, 20, 30, 40, 50, 60. Those are all multiples of 10, right? 10 has an infinite amount of multiples, right? You can continue to multiply it by greater and greater integers. So you could go on creating multiples forever. You could spend your whole life writing the multiples of 10. Or really any number. Any number should have an infinite amount of multiples because you can continue to just multiply it by greater and greater integers. So multiples, unlike factors, multiples will go on forever. So I'd like you to find the first 5 multiples of 4. So pause the video, take a moment, write down the first 5 multiples of 4. So the first 5 multiples of 4. We have 4 times 1, which is 4, right? 4 times 2, which is 8. 4 times 3, which is 12. 4 times 4 is 16, and then 4 times 5 is 20. Another way that some people like to do this is called skip counting. So you're counting by 4s, right? 4, 8, 12, 16, 20. If you're good at that, that's a perfectly fine way to think about this as well. But it is the definition of a multiple, right? Is the number times an integer gives you the multiple, right? And you can notice here we always start with, it's always going to be times 1 as our first multiple. So the lowest multiple for any given number will be itself, right? Okay, so let's talk about common multiples now. A common multiple is a number that is a multiple of 2 or more given numbers. So if we look at this nice Venn diagram here, we can see some multiples of 3 and some multiples of 4, right? So multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And the ones that they have in common, right, on our Venn diagram, they cross over. 3 and 4 both have 12 as a multiple, both have 24 as a multiple, both have 36 as a multiple. So these are common multiples of 3 and 4. So I want you now to find the first 2 common multiples between 3 and 5. You don't need to find more than 2, so you don't need to find a bunch of multiples for each of these, but find the first 2 common multiples between 3 and 5. So pause the video, take a second, and do that. Okay, so the first 2 common multiples between 3 and 5. So to find these, you should start by finding some of the multiples of 3, all right? So we've got 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So you can start creating a list of these. You're also going to need to find multiples of 5, right? 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. And then you're going to have to compare between these, right? These numbers are not multiples of 5, right? But 15 is. So 15 would be your first common multiple. You keep going, right? And I'll put this up here. We've got multiples of 3 and multiples of 5. The first 2 common multiples are going to be 15, which we get here. So 3 times 5 is 15, 5 times 3 is 15. And the next one is 30, right? 3 times 10 is 30, 5 times 6 is 30. So those are your first 2 common multiples. You could continue on and get many more multiples and common multiples, but In this case, I just needed the first two. Something to think about when you do this. So let's say we're looking at 3 and 5. As you're writing these down, you can think, is this number divisible by 5? If it's not, then it will not be a multiple of 5, right? So you're writing 3, you're at 6, 9, 12, 15. 15 ends in a 5 that is divisible by 5. So you know that this would be a multiple of 5, right? So keep those divisibility rules in mind as you're working through these problems. It will help you to not write too many multiples, because you could keep going forever, right? Okay, so here's a question. How many common multiples do any two integers have? So take a second, maybe talk to someone next to you. Think about this. How many common multiples do any two integers have? So any two integers have an infinite amount of common multiples, right? If we go back for a second, we've multiplied 3 by 10 integers and 5 by 6 integers, but you could continue on forever. Just like 10 has an infinite amount of integers, any two integers that you're comparing will have an infinite amount of common multiples because they will just continue to get bigger and bigger, right? So the lowest common multiple, what is the lowest common multiple? It is the smallest multiple that two or more numbers have in common. So it is a type of common multiple, and it is the lowest one. So if we compare like 3 and 4, we look at their multiples. The very first multiple they have in common is 12, right? So 12 would be their lowest common multiple. There's nothing lower than that for each of them. So what is the lowest common multiple of 3 and 5? So we did these multiples before. We found the common ones. What's the lowest common multiple between these? Take a second and write down your answer. Okay, so we found this before. I'm going to throw the Venn diagram back up on there. These are the common multiples we found, and 15 is the lowest common multiple, right? It is the lower number between these two, the lowest one between 3 and 5. So this process is pretty straightforward, and finding the lowest common multiple isn't too hard as long as you can find all of the multiples of these. Well, not all. As long as you can find multiples of these and then find the first couple common multiples.